Okay, so how is everyone today?
Good. All right. I went to the math lab and it actually helped.
All right.
I was reluctant to admit it at first, but I can see.
Well,
But you
know,
it's mandatory still.
yeah. Also, just as a matter of rationality, your tuition and fees pay for that service.
I'll try to wait for a little.
Okay. Well, when you say it like that.
Okay. So first announcement is that there's not going to be a quiz this week.
Thank you.
Yeah. Didn't get it over there in time, so we'll have to do. We'll have to pick up the pieces next week.
Oh, no.
You don't have to. Don't even have to.
We won't have to.
I just wrote it on there.
Okay. So we've gotta continue. So that's not focused, is it? Is it?
Slightly blurry. Slightly blurry. Yeah, that's very hurt.
Okay, there we go.
Okay. So let's see if we can solve a word problem. So what I want you to imagine is that there's two people and they're talking and having a conversation or whatever, and then for reasons that are entirely contrived, one of them begins walking east at 4 miles an hour, and the other one begins walking south at 3 miles an hour. Furthermore, they have walkie-talkies, and so they're in radio contact with each other. But these walkie-talkies, they only have a 2-mile range. So the question is that supposing these conditions, at what time do they lose contact? Okay. So I need an A name. What's an A name? Aaron. Aaron. No, just 2 A's, not 2 O's.
Everyone, do it, leave it.
All right. It's too late. So Aaron begins walking east at 4 miles per hour. Now I need a B name. Butters. That's fine. Begins walking south. Yeah. Brain is on slow-mo right now. Yeah, that's it. Okay, so their radios have a 2-mile range. How long until they lose contact? Contact. Okay. So what do you think? How should we attack the problem? Well, I suppose in the first place, hopefully we can remember the cardinal directions. So How about that? Okay, so what direction is up? Okay, north. Okay, and then you go clockwise, and then what's the phrase? Never eat sour worms. Okay. Never eat soggy waffles. Never eat sour watermelon. All kinds of whatever. Okay, so someone's going to the right, and someone's going down. The A person is going right. The B person is going down. So this person is going to the right at 4 miles per hour, and this one is going down at 3 miles per hour. So the individuals are here and here. So the distance between them at any given time is the length of this red line. So now, can someone give us a strategy for how we could solve this exercise? Okay, good. We've got a right triangle, and that red line is the hypotenuse of that triangle. But the question is how much time will elapse? So we need to come up with some names so we can properly model the exercise. So what variable do you want to use for time? T. Okay, T sounds good. T for time. And then what do you want to call this the length of this red line? D for distance, I suppose. That's good. I like that. So distance from A to B, call that D. Okay, but in order to express D, we'll also need to figure out, well, what is the formula for the distance from the start, where they started, to A. So that is to say, Aaron started here and then began walking to the right. So how far has he traveled after 1 hour? 4 miles. How far has he traveled after half an hour? 2 miles. So then, generally speaking, in terms of time variable t, how far, what is the distance from the start to A? So what if 2 hours have elapsed? How far? 8. How are you getting that? 4t. Yeah, 4t. So the distance from the start to A is 4t. So that is to say that, well, at the instant, at the beginning, when t is 0, the distance from the start to A is 0, standing right there at the beginning. After half an hour, traveled 2 miles. After an hour, 4 miles. After an hour and a half, 6 miles, etc. So what's the distance from the start to B? How far has Butters traveled? 3t. So when t is 1, that is to say when 1 hour has elapsed, Butters has traveled 3 miles. Okay. So then now now that we know these two, we want to express d in terms of t. So how can we do that? So specifically, I want a formula that's like d is equal to whatever. Pythagorean theorem, I agree. So somehow there's going to be a big square root. Okay, then what goes in there? Okay, very good. 3t all squared plus 4t all squared. Okay, and let's see if we can simplify this a little bit. So d is the square root of, well, that'd be 9t squared and then plus 16t squared. And then adding those together, that'd be 25t squared. Now I'll do the first part since it's somewhat straightforward. We can take a 5 out, and then it's 5t squared. Okay, then what? What is the square root of t squared? So I'll copy this last one, just copying it. Yes. So the square root of t squared is the absolute value of t. Now, we really would like to be rid of the absolute value. And under in a purely abstract circumstance, it just wouldn't be possible. We couldn't be rid of it. But because this is a modeling a physical problem, we can be rid of it. So how can we be rid of it? Right. Because let's consider this is modeling a physical process. At some point they were together having their conversation, and then they decided, okay, now I'm going to go my way and you go your way. Well, that's time 0. There was as far as the modeling is concerned, there was no time before that. So time is we're denoting it by t, and furthermore, because this is a physical problem, t is greater than or equal to 0. So then what about this absolute value? It's not needed anymore because of that observation. So the step from here to here is possible because t is greater or equal to 0. Okay. So if we were to make a brief sketch of this, this would be the t-axis and this the d-axis. So what would the sketch look like of this model? Line that passes through the origin, because if you plug in t is 0, then what is d? If you plug in Tom is 0, then what's the one for d? The phonetic word for d, like Tom for t, but what do you say for d? David, I guess. So if you plug in t is 0, then what is d? 0, right? So that means that you go through the origin. I'm trying to say these phonetically because some people can't hear the difference between T and D. It's hard. It's kind of hard to hear the difference. So through the origin, slope 5. Okay, now in a sense, I kind of only, it looks as if I've only drawn part of a line. Why did I do that? Right, so then I wouldn't want to continue drawing this over here because there wasn't a time before the experiment began, right? The experiment began when it began. If you were to plot it anyway, then you wouldn't want to continue it this going down anyway. You'd have to go back up. Why would you have to go back up? Because of the absolute value, right? It would be like you can imagine that all the time Aaron was walking this way, and all the time Butters was walking this way, and then there was a time before then, so their distance is decreasing, 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 0, and then increasing, increasing, increasing like this. So, like so. So what are we supposed to do to answer the question then? Now that we have a model. Set what equal? So in the end, the question is, how long until they lose contact? So that means you want to find something. What something are you trying to find? You're trying to find t. When will they lose contact? When d is 2, right? So the request is find t when d is 2. Because at that point suddenly the walkie-talkies will cut out. Okay. So 2 is 5t. So then we can divide by 5. 2 over 5 is 0.4 is t. So that means in a little bit less than half an hour. How many minutes is 0.4 hours? A little more. One less. 24, right? Because 60 times 4, anyway, would be 240. And a tenth of that would be 24. Good. So any question about this one? Yes?
Would you write it in like 0.4 or 24?
If you're best would be to leave it here, and the reason is because the units were given in hours. Yeah. So the answer is naturally most naturally in hours. In college algebra, I try not to play games with units, right? Where I could say, well, I give everything to you in inches, but I want you to respond to me in kilometers. Yeah, you love that?
It's like physics. You got that. That's why I lost all my points in my email.
Yeah, I'm not real sure of the pedagogical purpose of doing that, but pedagogy. Pedagogy means teaching. It doesn't you know, there's an inappropriate word that sounds like that. But pedagogy means teaching.
Look at this always up there.
Good. So any question about this? Okay. Good. So now we're in chapter 5. So this is section 5.1, which is quadratic functions. So a couple of remarks. So first remark is that every quadratic function can be expressed as f of x is ax squared plus bx plus c, but we're going to require that a is not 0. So why are we going to make that requirement? Right, because if a were 0, then it wouldn't be degree 2. Okay, so it would be just fine for b and c to be 0. That'd be fine, but a can't be 0. So that's the first remark, and then the second remark is that every quadratic function can be expressed as f of x is a multiplied by x minus h, that all squared, and then plus k. So this representation is called standard form. Okay. So notably, x appears just in that one place. But if you could multiply this out and collect like terms, then x would be in two places like this one is. Okay. So now let's try and understand this. So 3. If we take this right here, this formula, and I write the f of x as a y, then it looks like this. And so now what we're going to do is perform some algebraic operations so that you can tell exactly how this is as a transformation. So this k, which variable is it playing with? Which variable is it playing with? The y's, right? So only things that are inside the parentheses with the x are playing with the x. So the k really belongs over there with the y's. Okay, and then what variable is the a playing with? With the y's, again, because it's not in there with the x. So this would be y minus k over a is x minus h all squared. And what I want you to compare this to is the standard equation, y is x squared. So what is this one? So this one right here. This is the standard parabola, right? One of the ones that you're supposed to memorize. Okay. Then the question is that if you take this equation, which gives you the standard parabola, then what is this one?
Modified version of the standard
It is a modified version. In what way is it modified?
parabola. Starting position of the origin, narrow.
Okay. So I think you mean, when you said starting point of the origin, I think you mean this point, which is lowest.
Yeah.
Okay. So I I agree. The lowest point of this parabola happens to be at the origin, but you can imagine that I pick up the parabola and move it somewhere else. It'll still have that lowest point, and then it won't be at the origin. So we need a name. Need to give a name to that lowest point of the parabola, and I've probably slipped up and said it a couple of times already. So what is it? It starts with V. V, like Victor. Vertex, yeah. So the lowest point of the parabola is called the vertex. Even if you turn the parabola over, then the highest point is still called the vertex. So, what is the effect of this h here? Yeah. So this is in the first place, is it horizontal or vertical transform? Horizontal. And then is this h causing a shift or a scale? A shift. So this represents a horizontal shift. Then what about this k? Causes a vertical shift. And then what about this a? It's not a shift. It's a scale. And is it going to be a vertical scale or a horizontal scale? Vertical, because it's playing with the y. So notably, if a were, say, 2, then that would mean that the plot would be in a sense stretched by a factor of 2 vertically. If a were -2, it would still be stretched in the vertical direction by a factor of 2, but what else? If a were -2. What effect does negatively scaling the output do visually? Does it make it smaller? Not necessarily. Fishing for an R word. That is an R word, but not the one I was looking for. Starts with R.
What's the second letter?
Ends with eflection.
Reflection.
Reflection. Yeah, that's it. That was it. Okay, so then if a is negative, that causes the parabola to flip, to reflect down. Okay, so then there's two possibilities from this one. Well, I mean, there's infinitely many possibilities, but I'm going to break them down into two categories. So this is going to cause the vertex to move to position HK. So perhaps HK is, say, right here. So that's HK. And then here's another one that's at HK. And then if a happens to be negative, a negative value, then that's saying take the standard parabola and then reflect it down, so that it would look like this. So its vertex is at HK, and the parabola opens down. Its vertex is high rather than low. Similarly, this is the case when a is negative. Okay, and then are negative people smiling or frowning? Frowning, right? Even kind of looks like a frown, doesn't it? The little eyes. Then this, if a is positive, it looks like this. And even this one kind of looks like a smile. It's got a little smirk over there, that arrow. Terrific. So the jargon for this is that this parabola is said to open down, and then in my head I always say like a frown. And this one is said to open up, and then I always add in my head like a cup. Good. Sorry?
What if A is 0?
Well, then it wouldn't be a quadratic. If a were 0, then it would be flat. So you can imagine this a is negative. If a is negative but increasing, so like -10, -9, -8, that would have the effect of pulling these apart like a wishbone, pulling them, and then at the moment that a is 0, it's flat. And then when a starts to become positive, then it's coming up. Other questions? Okay. So I could ask something like, consider this function f of x is 3x plus 1 all squared and then plus 5. My request is please tell me the coordinates of the vertex. Decide if it opens down or up, and please make a sketch. Okay, so how about it? What are the coordinates of the vertex? -1, +5. The reason is because the standard form of a parabola from the previous page, I'm just copying down what was written on the previous page, is a multiplied by x minus h squared and then plus k. Notice that this one is expressed as a subtraction, but this one as an addition. And then hopefully, so in the first place, just matching the pattern. Can you agree that for this one, the vertex is at -1, 5? Okay. We can agree that just assuming that this is correct, then this is how it matches. Alternatively, I could ask, under what circumstance could you get the expression that's being squared to be 0? What would need to be true? The expression being squared here when x is -1, right? That's why this is -1. And then now to address the fact that one of these is represented with subtraction and the other with addition, why is that? Right, in a sense, this k belongs on the other side with the outputs. And then in that circumstance, they'd both be subtractions. But because we want them all to be on the same side for this formula, that's why the h looks like with subtraction and the k with addition. Okay, so then does this parabola open down or up? Up. Okay. It opens up because what's a in this one? 3, which is positive. And then to make a sketch of this, so this is just a sketch. So -1, the point, the vertex, -1, 5, in which quadrant is that? The second quadrant, right? And then using words left, right, bottom, top. Where is the second quadrant? Left, top. Right. So move left, move up. So something like this. and then it opens up. Okay. How about this one? How about p of x is equal to x squared minus 10x plus 3. And then the same 3 questions. What's the vertex? Is it open down or up? And sketch. Okay, so this one's a little more difficult than the previous one. Why is it more difficult? Right. So this one, the previous exercise, I gave it to you in this form, which is called standard form. So standard form is nice because once a quadratic is expressed in standard form, you can just read off the vertex, -1, 5. Whereas this one it's less clear what the vertex is. So before we can proceed, what we need to do is put this into standard form. Okay. So how do we do that? So we need to put P. We need P in standard form. So how do we go about doing that? It's something that's been missing from our lives for a few lectures. Not factoring. Something else that we just love to do with quadratics. Complete the square, yeah. Oh yeah, it's back. Yeah, here it is again. Okay. So P of x, so we'll collect the terms with x inside of these square parentheses since we're going to complete the square. Well, their proper name is brackets, but no one can ever remember. So now completing the square is adding 0, a fancy way to add 0. So specifically, we're going to add something and then subtract same something. So what are we going to add and also subtract? 25. And how do you arrive at 25? Right, it's half this number, which is 5, and then square it. And that's 25. You add this much and subtract that much. And the point of doing that is now the first 3 terms inside of the square parentheses can be expressed as a square. What square? X minus 5 all squared. And then we can conclude that P of x is x minus 5 squared and then minus 22. Any question about putting this quadratic into standard form? Okay, now that it is in standard form, you can just tell me the vertex. What's the vertex? 5, negative 22. Because remember, you're comparing it to this one. Okay, so does it open down or up? It's definitely one of the above.
Yeah.
It opens up. It opens up because what's the value of a? It's 1. A is 1, and the question of down or up is whether or not a is negative or positive. So 1 is positive, so the answer is up. Okay, then for a sketch, so 5, negative 22. So if that's 5, then that's negative 22-ish down there. And then from there it opens up. Okay. So, good news and bad news. So the bad news is that if I were to give you an exercise that's more or less just like this, and I say and the instructions go on to state and something like and do so by completing the square, well then you've got to complete the square. But if the instructions if the question is like this and it doesn't explicitly say complete the square, then there's a significant shortcut you can take. And so that's what the next remark is about. Now the cost of the shortcut, of taking the shortcut, is memorizing a formula. So let f of x be ax squared plus bx plus c with a not 0, then to put this f in standard form, a is exactly that a, that is to say they're the same. And then what are the other two letters that you need to know? H and K. So the formula for H is simple enough. It's negative b divided by 2a. Okay, and then K, its formula is negative b squared minus 4ac divided by 4a. Good old b squared minus 4ac. So what's what's that? That thing's so important that it has its own given name. The discriminant. Okay, so I hope that it comes as no surprise that we're talking about quadratics and the discriminant has come up again. Okay, so there it is again. Now, if you like memorizing formulas, then you can memorize both of these. If that's something that you like. But the shortest way to the goal is to memorize this one formula, which is entirely doable, negative b over 2a, and then to understand that the vertex output, that k is the output of the function at the vertex, is whatever the function is evaluated at the vertex input. That is to say that if you can memorize this formula for h, then you can always find k by computing h and then plugging it into the function. So let me explain what I mean. Suppose I give you this one. F of x is, say, 3x squared minus, say, 12x plus 5. So you could complete the square on this one, but completing the square would be even more of a task than the previous one. Why? Because this one is not monic, right? So every time you have a polynomial that's not monic, life becomes more complicated. However, this formula makes short work of this exercise. Suppose that it's the same three requests. Please find the vertex, down or up, and a sketch. Well, as for the vertex, the formula is negative b over 2a. And in this question, what is b? Negative 12, so that would be negative 12 over 2, and then what is a? 3. So the negatives cancel, and then that's 12 over 6, so that's 2. So that is to say that the input, the x-coordinate of the vertex is 2. Now we could now use this formula. But what I want you to observe is that k has to be f evaluated at 2. So now what I'm saying is just plug in 2 into this function, which is fairly straightforward. So plugging 2 into that function, that'd be 3 multiplied by 4, because that's 2 squared, minus 24, and then plus 5. So that'd be 12. Minus 24 is negative 12, and then add 5, that'd be negative 7. Okay, so then what's the vertex? 2, negative 7. And then what's does it open down or up? Up, right? Because a is 3. And then now a sketch. So 2, negative 7. Me too. And then one more component. I'll say, please write it in standard form. So how do you express this in standard form? So there's 3 parameters. Their names are A, H, and K. What's A? 3. So recall the formula. So that'd be A times X, and then what? Minus 2. And what do we do with that? Square it. And then what? Add K. Okay. So this is standard form. Very nice. So have a nice Wednesday.